Well, I guess I'll begin by introducing myself and my cohort. I'm Gary White, Department of Music, and Stefan Silverstone, Computer Science Department. We're going to be talking to you today about some current applications of the computer, or of computers, to music. The first part of the talk, I will be a bit general and give some kind of a background about the kinds of things that people are doing. In the latter part, will be a little more specific and deal with the project that we currently have going at Iowa State. When you bring up the possibility of computer applications to music or computer applications to the arts in general, one of the first things that often passes through people's minds is that old question of man versus the machine, and the suspicion that particularly humanists have that machines are in the process of indeed taking us over, and we're fighting a losing battle with them some way. To lay that question, I hope, to rest at the beginning, I'd like to think about that just a little bit. Man has used machines throughout recorded time. He built crude machines nearly from the beginning. And it's not a question of, really, I think, man using machines, or indeed artists using machines, because, for example, in the field of music, every musical instrument is a machine, isn't it? Except for the human voice and the sounds that you can make with your body unaided. Everything else that is used to produce music is a machine. And the question really, then, to me at least, is not the man-machine question, but what machine? And I suppose that probably part of our suspicion of the computer comes from the fact that it is relatively new, and as all the machines that we have been developing, relatively more powerful than the machines we had in the past. And then we're a little suspicious. This time, is the machine going to be more powerful than we are? Well, a little bit of programming that I've done has convinced me that, that indeed the computer is not all powerful. In fact, it seems to me rather a stupid kind of device. So I don't think that we're in imminent a danger of takeover by the computer. The idea of HAL in 2001, if you've seen that film, is a long way from happening. That is a computer that speaks back to one, that understands verbal communication, and indeed has a personality and presumably neurosis subroutines in there somewhere. I think we're a long way from there. I hope when we get there that the programmer doesn't write those neurosis subroutines. But at any rate, the idea of man versus the machine, I don't think is a terribly important question for the use of the computer in relation to music. Now, I'll give you a survey of the kinds of things that have been done and are being done. I'll try to be fairly current with that if possible, but also dip back historically. And you have to keep in mind that historically goes back to around 1959 in this field. There are projects going which deal with the analysis of music. Now, that is a matter of pattern finding and pattern matching in music. That's what we mean by analysis in music. Is largely a matter of pattern recognition and finding common shapes and patterns in music. There are a number of projects going which are computer analysis or computer-aided analysis to music. I just attended a symposium or a conference of the International Conference for Computers and the Humanities in Minneapolis, and there was a paper there by Fred Hofstetter from Ohio State University, which presented an analysis of string quartet literature during the 19th century in Europe, trying to find out if there indeed were distinctly national styles, trying to pin down what it was that made German string quartets in the 19th century different than French string quartets in the 19th century, et cetera, et cetera. That's an example of that kind of of a project, and there are many of those kinds of projects going on. Another kind of analysis that has been engaged in rather extensively is analysis of sound itself. We've known for a long time that sound was a horribly complicated phenomena. Particularly the sounds we deal with in music are normally very, very complicated in relationship to the simple sine wave producing oscillators that are often dealt with in laboratories. The actual sounds that we use for music are very complicated, and to understand the complexity of these sounds, it's been necessary to do a computer analysis of this sound. This kind of study has been done by Jean-Claude Risset, Max Matthews, and others at the Bell Telephone Laboratories, where they've been interested in the characteristics of natural sound. They're interested, for one thing, in speech synthesis, so that this kind of research leads them in that direction. Another kind of work that's been done with computer applications is a bit aside from what we ordinarily think about as music, but that is library and printing of music, producing bibliographies of composers and keeping them up to date, producing bibliographies of articles, which are kept up to date. The Common Abstracting Service for Music, RILM, is under computer control, as are most, I suppose, abstracting services. We're currently here working on a bibliography of computer applications to music, for example, with the help of Steve Foltz in the library. And that project is computerized. What we're doing is a keyword out of context bibliography. You can look up in a dictionary of keywords and find out all of the articles that are in the bibliography that have that keyword in their title. So it's a good aid to doing research in this area. Printing. That is a project that has been carried on several locations. Pattern recognition, recognition of printed music and outputting printed music. It would simplify publishing, for example. It would simplify music publishing tremendously if that process could be automated in some way. For example, an orchestral work is produced, and then you have to have a score and a set of parts. That represents double labor. If it would be possible, for example, to produce only the set of parts in some kind of semi-manual way and have the score assembled automatically, it would be a tremendous saving in time, and time is money. So that is an area that's being worked on. Recognition of printed music, perhaps for analysis purposes, you see. If you could put the page in front of some kind of scanning device and have the music stored automatically without any kind of hand encoding, it would be a great aid to storing scores for analytical purposes. Well, we get into the final two areas that I want to deal with, and one of these, it sounds a little frightening, and that is computer composition of music. A process that is being experimented with. It relates to artificial intelligence, wherein the programs the programs are developed by a composer or by someone associated with a composer to make compositional decisions. And then once these programs are made to make these compositional decisions, actual compositions are produced which exhibit the results of those compositional decisions. This gets us into the area of automatic music production. That, I must say, is in its infancy, if I can judge by my own aesthetic taste. It's in its infancy at the present time. I haven't heard anything that strikes me as being of a great interest musically. But there are a number of people working on that problem. That's not a problem we're trying to work on at Iowa State University, by the way. The last area, it relates to the synthesis of music, and most specifically to the synthesis of electronic music. And this is an area that we have a great deal of interest in here, and we have a project going in synthesis of electronic music with the aid of a computer. So I'd like to go in a little more detail with that. Maybe before we do that, it would be a good idea to look at the traditional flow of control in traditional music. In other words, to look at some kind of a flow chart for traditional music. And I'll present a few flow charts. Simplest one simply has a musician associated with his instrument with direct musical output. That's the improvising case. He has no printed music in front of him. He extemporizes the music. In other words, he makes his compositional decisions at the moment and applies these decisions to the instrument, and the outcome is music. Jazz, a good example of improvised music, or largely improvised music. Not all of jazz is improvised. The traditional case, where the composer presents or makes his compositional decisions and stores those compositional decisions in the form of some kind of a score, printed music or written music. He makes his decisions and he translates his musical decisions into some kind of notation, storing that in the score. Then a performer takes the score and does a translation process. He takes the symbols and translates that into musical decisions, which he then applies to his instrument, which result in music. And most of the music that we've known in the past is produced in this way. Or indeed, sometimes in jazz, combinations of these two, where certain areas of the piece may be written out and other areas left improvisatory. But most traditional music has been realized in this way. Now, what about the case of electronic music? Classical, and notice the word classical used in a peculiar sense here. The field is moving on rapidly enough that one speaks now of a classical studio. That means something maybe 10 years ago. And some of these classical studios are very much in existence today, but we use the term classical in that peculiar way. This is a rather more complicated situation. I hope you know what I mean by electronic music. I'll play an example of some electronic music in a moment in case you are not familiar with what I mean by electronic music. In this kind of music, the composer or the musician makes his compositional decisions while seated at an electronic music synthesizer. Now this may be anything from a very simple set of oscillators and filters through a very complicated and sophisticated kind of synthesizer. The one that's best known probably is the Moog synthesizer that was used to produce the switched on Bach recordings. But there are many others, other synthesizers like this. He makes his compositional decisions at the synthesizer. Advantage of that is he can try out the ideas and hear them directly, right then. He's not translating into some kind of a written notation, which he hopes a performer is going to be able to interpret. He's making direct compositional decisions based on what he hears. Well, the synthesizer output is recorded on a standard tape recorder. Generally, that is a very rough kind of output and has to be edited by hand. And by that, I mean that you actually physically cut the tape up in little pieces and put it back together again in the order that you want it finally to be assembled. So editing is a rather laborious process. It consumes more time than the size of the box indicates in that flow chart. Well, anyway, he produces a series of edited tapes, which are going to be the material of his composition. This series of edited tapes are then mixed using a mixer by playing these tapes simultaneously and recording them sometimes on 8 and 16 track recorders, he can overlay all the tapes and mix the result. This produces a final tape, or next to final tape, because generally there are some roughness left at that point that has to be taken out by final editing process, which again is a hand operation, a matter of cutting out sometimes very, very small pieces of tape. For example, when a tape recorder goes on or goes off, there's a momentary pop at that spot. Well, in the process of mixing these, you probably turn the main tape recorder on and off many times, so that there are many pops in the final product. Well, one goes through, and the pop is on about so much of tape, about an 1/8 to 16th inch of tape. And you go through and cutting out little 1/8 to 16th inch slices of tape to take every one of those pops out of the final product. And then you have the final tape. Final tape is played through a loudspeaker, and music is output. I'll play an example, or at least part of an example. If we get tired of listening to it, we can stop. Since it's my own composition, I may not get tired of listening to it. This is a piece I wrote 2 or 3 years ago now. It's a piece for violin and tape. The tape part is realized in just this process, just as I described here. Multiple tapes being gradually mixed down to a final process. The violinist on this recording is Ilse Niemak, who recently has retired from the faculty. That's the piece. That, by the way, I hope lays to rest the question of whether electronic music is doing away with live performance. Obviously, they needn't do away with live performance at all. It may be combined with live performance. Now, the problem of this traditional kind of tape composition is simply that it is very, very laborious. When a chord goes yat-ta-ta-ta-tum-bum, that was a little piece of tape that had to be edited in that tape just exactly at the right spot to coordinate. And every little detail represents a little piece of tape that's edited into the process, which is a very, very time-consuming process. Now, one would like to be able to get around this in some way, where you can make compositional decisions, hear the result of these things without this laborious process. And this is the kind of thing that people have been trying to achieve in the past few years. A system that was first developed to do this was a system called Music 4, Music 5. It went through various versions, in which a musician puts in a program to the computer in punched cards, which specifies either data to an existing program or in some cases user subroutines to an existing program. This fed the computer, it outputs a digital tape which represents the instant by instant amplitude of the sound wave of the music. 20,000 times per second a sample, for example, might be put out, which represents where the waveform of the music is at that point. The digital tape is converted to a digital to analog converter, and the output is a tape. Solves all that messy editing problem because the final tape is the completed composition in every detail. One little difficulty is that there's considerable time lag from here to there, because first you have to create a score, rather in a traditional way, and punch all of those cards up, submit it to the computer center, wait a day for your turnaround time, take the digital tape, normally take it to some other place to convert it to the analog tape, so that this may be a matter of days before you hear that decision. So the feedback process is very slow. I did use this process for the part of the music for the Christmas festival this last year. This music was done on a IBM 360 using a program called Music 360. And this, I promise, is a short musical example, but I would like to play you an example of direct computer synthesis of music. I'll have to say that I cheated. This represents several tapes from the computer which I manually mixed. So I wasn't purist about it. The time problems on a large computer are tremendous, and to produce any long section of music directly is a very, very expensive proposition. So I took that shortcut. But this is a section of music from the last Christmas festival. I think nearly everything in here is computer generated. Actually represents two computer tapes which I mixed together. There's only two computer tapes on that particular section. The bulk of the music was a single output of the Music 360 program. Now, honestly, I made all the compositional decisions there, and the computer was simply a musical instrument that I was using to realize the resulting music. Well, With that lengthy introduction, I come to the systems that we're dealing with currently at Iowa State. The difficulty with this last, I said, was the fact that you have this long waiting process to complete the loop between making a decision and hearing the output of that decision. There's a long loop process. You want to make that loop as short as possible. In fact, you would like to be in a situation where you could be at a machine, make the decision, hear the result, change the decision until you satisfy yourself completely. In short, you want this kind of process. This is one way, perhaps, of solving this. You want to be at a computer which you can communicate with conveniently in some way. It would be nice to be able to communicate fairly directly in ways which are meaningful to a musician. For example, by playing on a keyboard, or by at least typing in musical symbols that are recognizable, so that one doesn't have to learn a new language to do this, which, by the way, one does have to learn for Music 360. This input would be ground up some way by the computer and output directly to the sound producing system or a synthesizer. The output of the synthesizer, of course, is immediately available to be put on a loudspeaker, so you exist in a really closed loop situation. With immediate feedback, everything that you do, immediately you hear. The problem of making a decision and waiting isn't there. Also, the result, instead of being stored on tape, can be stored over in the computer and played back from the computer. All you have to do is put all of the data that you've generated in that process in some kind of a buffer in memory, and then you can draw it back out and play it again. So the recording process exists over here in the computer rather than out on tape. And that solves the editing problem, because that data can be edited as a list of numbers. We treat it like a list, and it can be altered in any way that you see fit. So that editing can be done internally to the computer, with the possibility even of making tentative decisions, trying it that way and saying, no, let's go back to the other one, without having cut a piece of tape in the process. And immediately the sound is there. You make a decision, or hope you've made a right decision, you hear it, and immediately you get feedback. So this is the kind of system that we're working on. I'll present a little bit more detailed flowchart, and I'm going to ask Stefan in a minute to talk a little bit about the computer software that we're developing for this system. This is an overall kind of flowchart for the system. The user will be out here. He'll be communicating through a teletype keyboard, or I should say, a Buchla keyboard. This is a keyboard designed by Donald Buchla at Berkeley, which has digital output. It actually connects directly to the computer, providing digital output from this keyboard, although the face of it looks very much like a piano keyboard. It produces data, which is available. Namely, it has an address for every key. You hit a key and it outputs that address. And that address may be defined anyway internally to the computer, so that you can change the definition of the keyboard by what kind of list you store of key definitions. Yeah?
Function something like a compiler?
Does this function something like a compiler? The keyboard? No, the keyboard is a very simple device. You strike a key, hardware produces, I suppose, an interrupt which says data's coming, and an address, a binary address of that key, shoots it out to the computer. The computer takes it from there.
You know, what converts what you're doing into something the computer can understand.
I guess at that level it does function like a compiler, doesn't it? I mean, some kind of an instantaneous compiler. That's a little... I'm talking to my computer science friend about that term, I don't know. But it does a conversion process, that's true. It converts from some kind of motion of your finger to some kind of data. I guess you'd have to call a teletype a compiler if you're going to take that kind of definition. I think maybe that may be stretching things a bit. Anyway, you communicate either through this keyboard or other switches which we may design freely there may be other kinds of controlling devices, but some kind of controlling device to the computer, which contains the operating system and the music programs, which Stephen will describe a little later. What comes out of the computer are commands and data for the actual interface processor, which is between the computer and the synthesizer, which is off the screen right down at the bottom here someplace. Let's go to the bottom of that chart. Control voltages, which are connectable to the synthesizer and actually will affect each module in the synthesizer, our output. Control voltage is simply a voltage which acts in the way an ordinary pot acts on a device. The higher the voltage output, the more you would have screwed the imaginary pot to the right, or vice versa. It's just a matter of putting out a voltage which does this automatically. And that's possible because you can put out a number which references that voltage and run it through a digital to analog conversion process and turn it into that voltage, feed it to the computer. Another thing is patch update commands. And these change the configuration of modules in the computer, in the synthesizer itself. There will be a patching matrix which will enable you to connect devices in the synthesizer freely and change those as the composition progresses, so that you're not locked into one configuration on the equipment, but can change it dynamically at time as well. That's going to be a difficult problem to solve. I don't propose to answer any questions in that area, but our people in Double E have a feeling that they can solve that problem. I trust them. Then all of this is fed down to the synthesizer. Sounds are produced and then out to a loudspeaker. Now that's about the way the system would work. We hope that the software, the computer programs, enable the composer to communicate with them in terms that are meaningful to the composer. That is, one doesn't have to learn some complicated set of hieroglyphics or some strange language filled with numbers to communicate with this program. That's a brief overview of the system, and I'll turn it over to Stefan at this point. We'll talk about the actual software itself.
Okay. Yeah. I thought I'd start with a discussion of essentially what the computer is for in this process. I'm not sure it's altogether clear what the computer really does for you here. One thing it does do is bring me into the process. But aside from that, does it have any other function? Well, first I'll talk a bit about representation of musical information. That is, what instructions need to be given for a piece of music to be performed. What do you have to tell the performer to do? What kinds of things do you have to tell them? And how do you represent it to them? If I start out then, case, I guess the first thing we could think about is simply a list of instructions, let's say written in English, which tell a performer, in this case, say a pianist, to press a key, hold the key down a certain amount of time, release it, and press another key, and so on. Well, we could certainly write musical scores this way if we chose to, and I guess from the standpoint of information theory, that's as good as any other way, but it obviously would not be particularly convenient for most pianists or composers for that matter. Eventually, a better notation system was developed, conventional music notation, and what I say here, I think, is what I said above in the list of English language instructions. Incidentally, I should point out that I'm not a musician myself at all, but my major achievement in the field of music is that I've gotten to the point of being able to draw these clef symbols in one. I'm very proud of that. Okay, now there are various other forms of musical notation, many of them developed specifically for electronic music. The languages that Gary mentioned previously, such as Music 5, Music 360, they all have types of notation that they require. And if someone is to use those languages to write their scores, they have to learn this notation. To me, such notational systems aren't a heck of a lot more complicated than this, especially when this gets even more, far more complicated than this simple example. But certainly for the average musician, it appears to be quite a difficult thing to learn these things. I've omitted them here. But I just point out that there's nothing particularly sacred about this traditional or classical notation. Now, in a computer memory, we can also represent the same type of information, same kind of information, if we have some way of getting it in there. For example, use this type of notation, each line of which represents we call a word in the computer memory. We might represent the score here in terms of two sets of computer instructions in a way. What we are representing here is the instrument. Well, in this case, let's say it's a piano or maybe an electronic instrument. Pitch and a duration, that is how long is that note supposed to be held. And we can represent in a fairly concise notation inside the computer memory essentially the same information. Now this is indeed a gross oversimplification of what actually has to happen, as is this. Because information about such things as dynamics, timbre, and so on, that's omitted in this little diagram as it is in this one. In the full-blown computer system, it would have to be included, and there'd be more information that would have to be present there. A basic idea of our system, which we're working on now, is to allow a composer to get his composition into the computer in somewhat this form. It's the first half of the process, in whatever ways are available or congenial to him. And secondly, to get this information back out of the computer into an audio device. In other words, basically process of input and output. Furthermore, this sort of internal representation represents the storage of the musical information over a long period of time in a manner similar to, let's say, a tape or or a score, or printed score. All right, now, just saying that one can do this sort of thing doesn't really justify doing it. That's sort of an odd idea, come to think of it. We're supposed to feel that anything you can do, technically you should do, right? But I feel that at least there's nothing antisocial or pollution producing about this. So and since we feel that it does represent a valid and valuable contribution to the art of music, I don't feel guilty about proceeding with it. Besides, it's fun. Now, what is really the justification of this sort of thing? To summarize what Gary has said before, mainly has to do with the ease of modifying your information. If we could compose, or people could compose, simply write the thing down, that's it, we're done, and that's the finished product, without ever having to go back and make changes. I suppose that the classical tape studio Gary described would be just as good as anything else. If people could compose things sort of in a vacuum and not merge parts together, not write for one voice and then another one and put them together, this sort of thing, then again, the classical tape studio would be quite acceptable. But that's not, in fact, the way it's done. People do have to make changes, and people do have to put things together. And it turns out that a representation of musical information in computer memory is one of the easiest ways for making pinpoint modifications. Each of these pieces of information, and of course they're just an example of thousands of such things perhaps in a typical composition, can be found and changed relatively easily at least from the point of view of the composer. You can contrast that with changing a little piece of tape, using a razor blade, I suppose, with some sort of adhesive, or making changes on a printed score. Presumably, if you have your score printed, it might be a little bit messy to go through it erasing things. I've never tried that. I've seen, in books on, say, Beethoven, where they show his scores with their modifications. And I would imagine he might have liked to have had a computer where he could change these things rather cleanly. I can't imagine how anybody could have read those things. So at least from my point of view, the key to the value of computerization here is ease of modification and adjustment, and so on. Now, the way our system is going to be set up is based on just this sort of thing. We think of a composition as being built up of successive layers, each of which carry a certain amount of musical information which will become part of a finished composition, so that one could compose, let's say, a melody or a part for one voice and polish that up, and compose a part for another voice and polish that up, put them together. So I'll try to show that pictorially by having luck with this device. Here, what I intend by this is, let's say someone has composed this. This would be... Has that been done before? And has entered that into the computer. And I'll talk about how that's going to be done later. I want to get the concept across first. Let's
Actually,
see.
Stefan, it's G, 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 E flat.
Well, everybody knew what I meant. I told you I wasn't much of a musician. I'm just in the wrong key. I think I had the right interval, didn't I?
You're a half step.
Well, just a half step off. Experimental error. You would mention that, though. I was hoping. At any rate, this will be translated, and I won't mention exactly how this got input into the computer, but eventually it will be represented by a certain number of cells in computer memory that representing information. That might be one layer. All right. Now, the composer may have certain dynamics in mind that he wants to use, and he may have developed that separately. So, another layer, which might be superimposed on this one, composed at a separate time. And maybe another voice coming in here, which is superimposed on that. So you notice that the computer program, the composition is stored in computer memory, gets a bit larger as the composition is built up. Anyway, this sort of pictographically is intended to show our compositional process. Inside the computer, in the processing of this, it's a little bit more complicated in the way I've shown it. I just couldn't figure out a really great way of drawing it, but actually what happens is not so much that the green, blue, and red lines are put in one after the other in the way in which we introduce the layers, but actually they're rather merged together so that things come out in the right order. It's sort of a sorting process. Of course, things could get a bit more complicated. You know, as we can compose in principle a whole symphony like this. Several voices. That, of course, depends on the capability of your system as to how much hardware you can support. You know, how would somebody, at least in our system, go about doing this? The first thing you do is sit down at our teletype, which is connected to a computer, and we would have to learn a little bit of our language, but our intention was to make this as god-awful simple as we could. So we're trying to use English words, we're trying to avoid exotic symbols and so on. The first thing you would do is say compose and give a name to the layer that he wants to be composing at that time. He might have some information that he wants to give about the way the electronic components are supposed to be set up. You can do this to the extent that he wants to the extent that we have electronic components available. If he doesn't want to do any of this, he doesn't have to, because there will be a nominal electronic configuration representing some nominal electronic instrument that will be used if the composer doesn't want to specify his own. And this idea, which is called in computer jargon default conditions or default option, is, I think, basic to our concept. It should be basic to practically everything in the computer business. Unfortunately, it isn't. Unfortunately, very often, I don't know, any of you have used our computing center here, you find that you have to specify, whenever you run a job, a whole bunch of things that you couldn't care less about. that's the IBM concept. You know, make you write down a bunch of meaningless garbage, which you find out from somebody else who knows what it is. He doesn't understand it either, but he tells you what to put down. We want to avoid that completely, especially when we have, our users are essentially not computer types. They're basically composers. Okay, next thing our composer might want to do is write his music. Okay, we have our keyboard. You can sit down at that keyboard and play, and he can listen to what he plays while he plays it. Simultaneously, the information that he's played will be stored in computer memory and will form one of these layers so that he can retain it and use it later, perhaps in conjunction with something else. Okay, after he's finished this process, he can stop playing, go back to his console, and go back to the teletype and play and compose something else. He can continue doing this as long as he feels it's necessary. Okay, now, you may want to hear how something sounds and edit it, in which case we will have the capability of running our system in edit mode. That is, he can play back his composition, stop at any point, and make a change. So he can listen to something, goes da 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 da. I don't like that part. I stop here, go back, hit the keyboard like ding instead of dong, and be entered in as a change, and from then on, the new version would be what is stored as the composition. Okay, we then have, we call the capability for the composer to sort of play a duet with what he has previously composed. That is, he can play on his keyboard. What he's played goes into computer memory to form a new layer. He can simultaneously call in a new, or rather a previously composed layer, and they can play along together so that he can listen to, let's say, himself playing one voice of a composition in accompaniment with the previously composed composition. It's sort of like music minus one. I want to think of it that way.
And the union is being able to store all three of those, the old, the new, and the combination?
Sure. Yeah. Ultimately, we hope to be able to have someone playing, you know, not only a duet, maybe a trio, quartet, several concurrent, previously composed layers. We also, at least we think it would be nice if we can work it out so that he could. Is that phrased vaguely enough so I'm not committed? We'll have the capability of changing the tempo of these previously composed layers in accordance with the way he's playing the current layer. For instance, if he wrote something as an accompaniment for something he's playing now, and he finds that his accompaniment is too fast, he can slow it down while he's playing. That will be a neat technical trick. I think we can do it. Now, should perhaps say a couple of things in closing then. What happens inside the computer while this process is going on is that there's a processor which essentially goes from looking for keyboard input to looking at previously composed layers, goes back through them, looking to see if there's something that should be done now. There's a clock that's ticking, and it keeps checking the clock to see if something should be done. When it finds that something should be done, it outputs it to the synthesizer, and that gets played. Incidentally, of course, the output can go both into speakers and into tape recorders, so that we can ultimately get the permanent record of composition on tape, although, of course, in a sense, what's in computer memory is also a permanent record. It can be made such. And that can also be put out on tape, different kind of tape. The processor, which was spoken of, which takes care of this sort of thing, is essentially what would in the computer world be called an interpreter, interestingly enough. It looks at some sort of intermediate form of data stored in the computer and performs things according to what that data says. It's interesting that the same word is used in music. In exactly the same connotation. An interpreter is a performer who looks at a score, which is sort of an intermediate form of data representation in between what was in the composer's mind and what goes out over the air, and he performs according to those specifications. The difference is that the computer interpreter interprets exactly, and the human classical interpreter lends something of himself to the process. But somewhat interesting that the English word happens to be the same. I might point out in closing that type of system that we have here represented, which essentially involves certain actions to be taken by the computer in communication with something in the outside world, need not be restricted just to musical representations. The information, as far as the computer is concerned, could involve lights, for instance, or any other sort of phenomenon. So that effectively our system could eventually expand into a multimedia system. Question? Yeah, so that basically while we're starting rather small, we had all kinds of grandiose ideas. I perhaps should mention one other point, that perhaps some artificial intelligence could be incorporated into the system as part of this interpreter here, so that we could, in fact, make the computer essentially an interpreter in the classical sense as well. And I think now we might entertain some questions if they're not too hard. Colby?
I'm getting the impression here that the composer might be somewhat limited by his keyboard facility. Now, what's the teletype do with the keyboard? Does that
Okay.
pass around that problem at all?
Well, it's true that he is somewhat limited because, but any user of a keyboard is limited by what that keyboard can do. The teletype is simply the current means of communicating with a computer and giving it, say, numeric information, commands as to what to turn on, what to turn off, and so on. There's certainly some room for improvement and expansion in that area, and the keyboard essentially is supposed to convey more direct musical information.
Maybe I can say a couple things about that. One could have a system of code which could be put on a teletype directly, and we have provisions for creating such a code. Two, with the edit facility, if one makes a mistake, it can back up. So, two of those things in combination.
Well, I was thinking the same kind of question. A question like, for instance, do you initialize that if I press this particular key on the keyboard, I will generate a set of harmonics appropriate to the sound of a violin or a trumpet?
Yeah,
or a harmonica?
we can pre-program each key on the keyboard as we choose if we want to. Or we can use a nominal definition for the keys.
Right. Can you also change the pitch? Or
Yes.
is it constrained to?
No, it's quite free. These can be quarter tones or, octaves or whatever.
In point of fact, the keyboard may be designating things which are not pitch at all. A definition of a key might mean, put the system in a configuration. Repatch the whole system. You hit the key, the system gets reconfigured.
He's
So
actually saying that you will have complete control of the keyboard, not any of you.
that's exactly right. You define the keyboard.
Of course, this kind of freedom is a dangerous thing. I'm kind of afraid of what people will do. We hope to build in some constraints such that people will not burn out the hardware by means of this sort of thing. That can be a serious problem, and in some studios they have had such things as destroying your tape recorders every other week. Oh, I'm sure, and a few others too. Yes.
At present, the composer, however, for his original composition is committed to one layer for a moment of composition.
And that's
No,
not correct.
no. No.
You can merge layers. You can lay one layer on top of another, on top of another, on top of another.
But where do the other layers come from? If he only has one keyboard, which at that
Oh,
instant program.
okay, I see. Okay, he can use the keyboard, compose a layer, store it. Go
We
back.
have to recall the other layers in order to do multi-layered work.
That's
You can't
true.
do more than one layer per instance.
Well, at the moment, we only have
One keyboard.
one keyboard. So, but there's nothing in principle to say that we can't have more than one.
But of course, hitting a key, what you're saying is you can hit only one key on the keyboard at a given time. That's what you're really saying. The definition of that key may be as complex as you choose, or within certain limitations. And so the actual event that happens when you hit the key could be a very complex event, rather than a simple.
That key could be programmed to several layers of sound.
The key could initiate a layer. That's exactly.